In this video, looking at ECAA 2020, Section 1, Question 15. So we have this triangle here, PQR, and we can see that it's split into two different right-angled triangles. This angle here is 61 degrees, and we've got some different lengths, x, y, and z. And we're asked, what is z in terms of x and y? So how are we going to work this out? Well, let's find an expression for z, first of all. So I'll move this half triangle over here. Let's find an expression for z. How would we go about that? Well, this is a right-angled triangle. So what do we know about these two sides? The one I've labelled A here and this one Z. Well, we know we have the angle that's opposite, the sign that's opposite the angle, and the line that is the hypotenuse. We've got the opposite and the hypotenuse. So what do we know about a trigonometry equation we can use for that? Well, we know opposite over the hypotenuse is the sine of the angle. So we can work out an expression for z. We can do a over z equals sine 61, our angle here. So z equals a over sine 61. So now all we need to do is work out what a is. And how can we do that? What other information do we know that has a that we can use to work out this equation? Well, we have this other triangle here. So A is our side there, and we have y and x. So how can we find out A in terms of x and y? Well, because this is a right-angled triangle, we can use Pythagoras. A squared equals b squared plus c squared. So a squared is going to be our hypotenuse y squared here, and our other two sides are x and a there. So x squared minus y squared minus x squared equals a squared, because a is the thing we're looking for. We can square root that. A equals the square root of y squared minus x squared. So now we have our expression for z and our missing variable. We can put them together. Z equals the square root of y squared minus x squared over sine 61. Our final answer is F.